Hi, my name is Derick Downey, and welcome to CI/CD with Kimball International, a case study. So over the past year, I've implemented a CI/CD pipeline for our development team, and prior to this, we had no pipelines in place, and I honestly knew nothing about DevOps or CI/CD. So this presentation is a reflection or an encapsulation of everything I've had to learn over the past year in order to get from no pipeline to working pipeline. So who am I? My name is Derick. I already said that. Little bit about me. I used to be a professor of arts technology at Illinois State University, and then I entered the smart home industry for about 6 years, where I was working with, I was a trainer and then programmer of Control4 and Crestron and Elan systems. And then I became a CET developer about 3 years ago, and I've been loving it. So what do I do for fun? I hang out with my family. I hang out with my wife, my baby, my 2 dogs, Peanut and Butter. And I work, I program, I go to coffee shops all the time and just work on little programming projects. And I still do music sometimes. So a lot of Ableton and Maximus P and stuff like that. Again, I'm not an expert on this. This is not a best practices. This is what I've learned so far. This is not your pipeline should look like this. This is what my pipeline looks like now that I'm a year in and we've gotten it working. So something I want to call attention to right off the bat here for the CET developers. I know everyone uses GitLab by default. Our team switched to Bitbucket a couple years ago. So all of this is using Bitbucket pipelines instead of GitLab CI/CD's pipelines feature. So even though we're using Bitbucket, you guys might be using GitLab. The concepts are the exact same and the knowledge will transfer from one to the other. What you may notice is slightly different syntax when writing your YAML file or slightly different uses of words. So for example, like what GitHub calls a job, Bitbucket might call a step, or GitLab might call a script. So all similar words used in different ways, but the overall concepts are going to be relevant no matter which one you're using. So here's my agenda for today. We're going to start with the end result. I'm going to show you what it looks like when we have this pipeline in place for our Jira development workflow. Part 2, the concepts. That's more the wide view, what is DevOps kind of generic concepts that are important to know. Part 3, the cast. So then narrowing down from the wide concepts, we're instead going to get to who are the actual players involved. What are all the moving parts involved in order to get a pipeline working? And then part 4 is going to be the code, where I bring up a bunch of screenshots of the actual implementation of our pipeline and kind of walk through it with you guys. So let's get started. All right, part 1, the end result. So why did we implement CI/CD? Well, because devs often like to submit code that doesn't compile instead of code that compiles. And they could catch this if they compile all below before sending to code review, like Bernie is requesting here. But they don't always do that. So the first benefit of our pipeline is that whenever a pull request is created or updated, the branch that they are submitting or that they've created the pull request for is built. So as if you go to Build Center in the CET developer tool, it attempts to build that branch of the code they're submitting. And then if you look off to the side in our Jira, you'll see that there is a one build and a checkbox that's green. So if I zoom in on this, now anytime we look at a ticket, we can see immediately whether that branch compiles or not, whether it builds. So we don't accidentally merge code that doesn't build into an important branch. Here you can see an example of some code that was submitted where it wouldn't compile. So if I zoom in on that, you'll see that this says the build is failing. So we can see at a glance whether the branch is compiling or not. On top of that, we also have notifications set up. So notifications for Microsoft Teams, which I will show you how an overview of how we got that set up at the end as a bonus. So we can get a Teams notification when a build fails. And our team also uses Slack more recently. So we have Slack notifications enabled as well. That basically, if a build fails, I get informed, and it's very useful because then I can investigate why it failed. Also, I have a whole build log parsing system set up. So when the build fails, if they click on the link, then it will take them to this page. And then if they go to the bottom, it will actually pull out all of the compile errors. And you can see right there what the compile errors are. So the developer doesn't need to download external log files. They can just see it within the Bitbucket Pipelines UI, essentially. However, if they do want the actual log files, if you switch from the Build tab to the Artifacts tab at the top, you'll see that we have 4 different things they can download. Build errors is that text file that I just created that I just showed of the compile error log parsing. But then you have build logs, which is the original logs, and then build output, which is the actual binaries that were built. So you still have access to those. Benefit number 2. So the first one was it does automatic build tests, essentially. We weren't actually uploading or doing anything with those builds. We were just checking to make sure that their code compiles. Benefit 2 here is we are actually building and publishing with a single click. I'll say that in asterisks because in this UI right here, it's technically 3 clicks. You have to click branch, then you have to click the pipeline, then you have to click run. However, that's it. So normally this can take 10 to 20 minutes if a developer is doing this on their own machine, and you have to walk through the Build Center UI within CET Developer, which is not too much of a hassle, but it's much easier now that anyone could build and publish a branch at any point. So this is not only going to build the version 16.0-beta branch, but it's also going to upload it and publish it to our beta distribution build box. So just a recap here of how our team's workflow is. We essentially have 3 layers of defense. We have a dev code review. So you submit code, and then it goes through a dev code review and a dev QA test. Then once it passes that, it goes to a beta code review and a beta test. And then it goes through an RC code review and an RC test. So prior to having the CI/CD, you can review the code. You can say, yeah, this looks great. And then you merge it into the branch, but now you can't build the branch. And you're like, oh man, I was supposed to get the beta build out this morning, but now, so-and-so's ticket, his changes are preventing me from building the beta branch. Can you go in and fix that and then let me know ASAP so that I can build the beta branch? But after CI/CD, we'll never merge code that doesn't compile. There are still integration tests. We'll get to that. So there are still situations where it could end up in a situation where it won't build, but we'll talk more about that later. So now with the CI/CD pipeline, the areas in magenta, the code review, basically we're saying we do a build test prior to the code review, so we know that branch compiles. And then the light blue shows that anyone can publish the code or the branch into the distribution environment. It could be a project manager. It's still developers on our team, but overall, it just makes that publishing process much easier. Future goals. So these are some of the things which we haven't implemented. We just haven't had time yet, but over the next year, we definitely plan to. So this is all using Bitbucket pipelines. It's all happening through our repo, and we don't actually leverage any Git hooks, which is like the difference would be Bitbucket pipelines is all stuff that gets triggered from the remote repository. Git hooks is stuff you can do on your local computer before it gets to the repository. So, for instance, you could in theory, make it so that before they upload a code change, it does a build on their own computer in order to make sure that it does build. Whether you want to do that on everyone's computer or whether you want to farm it out to an external server so that their computer isn't doing builds all the time, that's up for debate, but I just want to make sure that we pay attention to Git hooks moving forward. Integration tests. So currently we only know if the code that they are submitting compiles. We don't know after we say we have 10 different pull requests pointing to beta. We don't know if beta will still compile after all 10 have been merged into beta. So that's something that's on our list to implement, is basically do a dummy build of all of the branches that are targeting another branch. So you can catch errors before everything's merged into that branch. And another goal here is the automated CET tests, which I'm really excited to get into. So I have some very magical code at the bottom here that took me a while to figure out, and you guys can start from scratch with it. So this is how to call a CET or a CM function from command line. So if you think about it, all of the pipelines run through command line commands. So in your pipeline, you can actually start calling CM code within your pipeline and do things like just run automated end-to-end testing within CET. So I have some more resources at the bottom for you to explore with that. Recap of part 1, the end result. So all of our ticket branches are test built before anyone reviews them. Build and publish is now a single click, and this process opens the door for integration tests and automated CET testing. All right, part 2. So now you've seen what we're working with, which again is not super impressive, but it's the foundation which our team is going to build on moving forward. Part 2, the concepts, DevOps and CI/CD. What is DevOps? DevOps stands for Developer Operations. If you look it up online, you'll see all over the infinity symbol is associated with it. So you have the DevOps or the developer side of things on the left side, you have the operations side of things on the right side, and it keeps going back and forth in this process, which is why they have the infinity symbol. What is DevOps? So DevOps is a ton of things. It's kind of an umbrella term that captures a ton of different things. So it could be infrastructure as code. It could be continuous integration, which is CI. It could be automated testing. It could be release management. It could be feature flags. It could be all these things listed here. So just recognize that DevOps is an umbrella term that captures a lot of different concepts. So early into my journey, I spoke to Archie Brentano. He is a DevOps engineer with 10 plus years experience. There's his LinkedIn. So if you are interested in, talking to an expert or hiring a consultant on the side, that is how you can contact him. He asked me, he's like, what do you think DevOps is? I gave my answer, and then I asked him, what do you think DevOps is? And he said, there are 2 definitions that I know. The first is taking a developer approach to operations. The second is giving the power of operations to developers. So let's break that answer down. Definition 1, we have a dev approach to operations. The crux of this is automating repeatable processes, writing scripts that get run, that accomplish a task that you normally would have to do by hand, that is repetitive and is able to be done as a script. So some examples of this on the infrastructure side, you can write scripts that automatically configure computers, automatically set up servers. That would be infrastructure as code. So you could think of a new developer on your team that's going to be a CET developer. You could potentially set up a script that installs CET developer and handles all the different things you have to go through in order to get your computer set up. That would be like infrastructure as code. On the code repository side, you could set it up so that when your repo fires a trigger, essentially, when an event happens on your remote repository, then something happens. A task is done. That is like the example of when a pull request is created or updated, we do the task of automatically attempting to build that branch. On the end user side, you could do things like automatically run an A/B comparison of a feature and generate a report after a certain amount of time, things like that. So definition 1, automating repeatable processes using scripts. Definition 2 is more limited, and it's really just, can the dev team deploy their code without help from an outside team? That seems to be the overall idea of definition number 2. Give the dev team power to publish code and publish code to the end user directly without needing help from another team. Within the CET development world, it is pretty much already in the hands of the developers because we have Build Center, and so we can just deploy the code using the web portal, and we don't need to get help from an operations team. So Archie also gave me this. This is some talking points you could bring to your higher ups if you're interested in explaining what DevOps is good for. So it helps you create a dependable process that leverages both software and hardware to produce quality code. You can, the goal is to provide a stable platform that is auditable and defined programmatically, resulting in less friction from development to release. Because if there's an issue, you can figure out exactly when the issue happened and what the environment was at that moment when the issue happened. And it also, the goal is to provide useful and timely feedback to developers about their code, causing quality assurance activities to shift left. Another way to say this is through memes. So, you have users finding bugs in release, which is, okay, not really that good. Then you have QA finding bugs in beta. Okay, then you have devs finding bugs in code review. Then you have robots finding bugs when the pull request is created. That's pretty awesome there. So in the last slide, the slide prior, I used that term shift left. That is a DevOps term. And the idea there is when we showed that infinity symbol, you have development on the left side, you have operations on the right side. So to say it's going to shift left, like catching bugs and stuff like that is going to shift left, that means you're going to catch the bugs during development, not after it's been released and it's out in the world. So here you can learn all about these different stages. Different infinity signs have different steps. This was the one I pulled from Atlassian's DevOps resources. And after really thinking it through, the summary I kind of came up with here is so that you have, I start at the discover spot. And discover is when you decide, what are we going to work on? What's the team? What is a problem that we need to address? What are we going to spend our time on? Plan. Okay, now we've decided what we're going to work on. How are we going to work on it? What's the strategy? What's the technique? As developers, what's the way we're going to accomplish this ticket or finish it? Build. So here it says build, but really that's like develop. It's the developer knows what to work on. They know how they're going to work on it. Now they just have to do it. Then test. They're going to test it, right? So this is your QA is going to test it. And between that build and test step, it's not going out to the final end user at this point. This is the back and forth between QA and the dev team. Deploy. Now you actually release it. And then, so that for us would be the uploading to Build Center and posting on the official 64-bit. So then operate. Are we all good? Is everything rolling out okay? And then observe is like monitoring. So operate is like, is it working? Are there any critical errors? At least this is my understanding of it. Are there any critical errors? And how how has the release gone? Observe is like a constant monitoring of the health, the metrics of what your entire application, essentially. And then continuous feedback. So now based on what we're observing, how the release went, and this entire process, what did we learn? And then bring that back into what we're going to decide to do next. So that's the DevOps. We've talked about DevOps. Now, what is CI/CD? So DevOps, here I have another definition from Atlassian. It is a set of practices, tools, and a cultural philosophy that automate and integrate the processes between software development and IT teams. So it's a very generic concept. CI/CD is a much more specific concept. CI/CD, short for continuous integration and delivery, or deployment, we'll get to that, is a set of practices that automate the process of building, testing, and publishing software changes. So DevOps includes CI/CD, but DevOps is more than CI/CD. And one thing I'll also mention is that CI/CD, the C stands for continuous. It is a spectrum. So you can have a CI/CD pipeline that is not entirely continuous. Maybe people would argue and say it's not CI/CD, but you'll see what I mean in a minute here. So continuous integration. What is continuous integration? Well, what is integrate? To integrate means to render something whole, to bring together the parts of. You think of an integer as a whole number. Integrity is someone who is complete. They're not fractured. So continuous integration means to continuously bring together all the parts. An integration test, if you've heard that term, an integration test, which I mentioned earlier, is you take all of the proposed code changes and you bring them together into one whole, and now you test them all working together. It's almost like taking a bunch of things that have been siloed off into their own little silo, bring them into one thing, and now test them as a whole. So continuous integration, CI, is the practice of integrating source code changes frequently and ensuring that the integrated code base is in a workable state. So this is the best way I can think about this. This is how I understand this. Continuous integration is you are constantly taking code changes and merging them back into the branch that everyone is working out of. The exceptions for this would be like a feature branch that would break things. You don't want to merge it back in. But if it's like a bug fix, this is the idea here. The developer for Jira ticket 111 would branch off of the main branch. They would do their code changes, and then they would submit the code change. That code change, if it was a fully CI system with no manual stops at all, it would go through all sorts of automated testing, and if it passed all of those tests, it would get merged back into main. So that's bringing together the parts into the whole. Then, say another developer does Jira ticket 222 later on. When they branch off of main, those code changes are actually already in their branch. So that's what continuous integration means, is that as a developer submits code, that code is getting merged into the working branch as soon as possible. That's what a fully continuous system would look like. So the goal, I basically already covered all this, but the goal is to merge all of the code changes into a main branch as soon as possible. So that's CI, that's continuous integration. What's CD? Well, there's actually two different types of CD that you'll come across, that I've come across while learning about this. There's continuous delivery and continuous deployment. So first here, I'll just mention continuous integration. Code changes are automatically tested and integrated into a main branch. Continuous delivery is that main branch that has had the code kind of merged into it as soon as it's done. That main branch can be delivered to a test environment or a production environment at any time. So continuous delivery means At any moment in time, you could press a button and that main branch gets deployed, gets published, gets accessible either by your QA team or by your end user. So that's continuous delivery. Continuous deployment is that main branch is automatically deployed, basically, as I would assume, after the integration tests pass. So main branch is automatically deployed to environments multiple times a day. An example I heard in this one YouTube video was that Etsy deploys a new version of its website up to 50 times a day. Because if a developer submits a code change and it passes all the testing, well then just make it live. So that's the difference between continuous delivery, is that you can deliver at the press of a button. Continuous deployment is it's automatically delivered all the time. CI/CD and CD and CET. So is continuous delivery a good idea for CET development? Because again, remember, when we publish something live, it's gonna take the user a couple minutes to download. So is continuous delivery a good idea for CET development? I think so, because then non-developers can do a test or release build without help from a developer. Is continuous deployment a good idea? Probably not, because then the end user, if we're doing 20 releases a day, that end user is going to be downloading a new extension all day, all day, every day. So for QA build boxes, maybe would make sense, but I have experienced that the software slows down when the download is happening. So I would say, and I could be wrong, but I would say the continuous delivery is a smart idea for CET development, and continuous deployment, I would have to be convinced on. An honorable mention here, you will see also DevSecOps. So DevOps, developer operations, Sec is security. And the idea is they build security into the entire process. So you're thinking of security during the planning, during the coding, during the building. And it's not just like, oh, we're about to deploy. Is this secure now? So that's what DevSecOps is. All right, so recap. DevOps, taking a developer approach to operations. CI, running automated tests on submitted code and then merging it into a main branch. CD, continuous delivery, can be delivered at any time. Continuous deployment is it is automatically deployed all the time. So that ends part 2. All right, on to part 3, the cast. So in this section, I'm going to cover all the various players involved in a pipeline. And it's going to be a lot of information, and it's going to kind of feel disjointed at times, possibly. So in order to tie us all together, first, I'm going to give us a mantra. This is going to be our sacred mantra that we can return to when we are feeling anxious about all of the information I'm about to throw at you. So what is this mantra? CI/CD is about scripts that control other computers. If this is ever feeling like a lot of information, just return to this phrase. CI/CD is about scripts that control other computers. If you think about it in terms of that, then I think you'll be able to, you can look at the player or the cast member and then see where they fall in relation to this concept. So let's meet our cast. We're going to go through pipelines. We're going to go through runners, shells, YAML, repository variables and secrets, and artifacts. So let's get started with pipelines. What is a pipeline? A pipeline is a chain of automated tasks triggered by some event. So for example, you could have a chain of automated tasks triggered by when code is pushed to a repository, or when a pull request is created or updated, or at a scheduled time at midnight every night you could have tasks run, or a manual run. So manual run is in like pressing the run button in the web browser. So pipeline example, here's just a chain of tasks. When a pull request is created, you could try to build it and then if it builds, try to merge it into a fake version of the beta branch, and then if there's no merge conflicts, then actually merge it into the beta branch. Then, or rather, you would probably try to build the fake beta branch so that you can test for integration tests. Then you would merge it into the actual beta branch. Then you would build the beta branch. Then you would publish the beta branch, and then you can send out notifications to anyone who needs to know that, hey, there's a new build. That's an example of a pipeline. It's a whole series of different tasks that get triggered by one event. One thing I'll call out is that you can have one pipeline, or you could have multiple pipelines. In our system, we have multiple pipelines, but you could just have one massive pipeline that does everything. Here's another example I pulled from Atlassian. Here they have about 8 different steps here, and if it fails at any point, it goes back to the beginning of the pipeline. So you could break this up into 3 different pipelines. Maybe the unit tests, maybe from commit, build, and unit tests, that is just one pipeline. And then maybe merge to trunk integration tests is a separate pipeline. So just saying that the whole idea is it's a chain of tasks. It could just do one task, but typically it would be doing multiple things. So CI/CD is about scripts that control other computers. A pipeline is, what do we want the other computers to do, and when do we want them to do it? That's what a pipeline is. Moving on to our next player on our stage here, we have runners. What is a runner? A runner is a computer. It is specifically a computer that listens to the pipeline, so it is connected in some way to your remote repo, whether that's Bitbucket, Bitbucket Pipelines, or GitLab CI/CD. So it is a computer that runs the pipeline. It's the thing, when we said before that a pipeline is a chain of automated tasks, the runner is the thing that does the automated tasks. It's the computer that gets run. So like I said, it listens to your remote repo CI/CD service to know when to run what. So it has to be connected to your service in order to receive those events. The runner could exist in the cloud or on your desk, and it could be ephemeral or persistent, meaning it could be a computer that literally sits on your desk and is your personal computer, and it's a persistent computer. It's like a persistent server. It's a computer that's going to exist after the task is done. Or it could be ephemeral, which is it will be a server that gets spun up in the cloud, created to run this job, and then after it runs the job, it gets torn down and that computer gets deleted, essentially. So that's the differentiation I'm calling out there. The computer, this is pretty obvious, but it's going to have an operating system, whether it's a Linux distribution or Windows or Mac. And then that computer executes commands within a shell. We'll return to that. So a runner, all of the commands get executed on that computer within a shell. You can have multiple runners with your pipeline. You could have as many runners as you want. And then within Bitbucket Pipelines, they have a thing called tags that every runner, you can give it whatever tags you want with custom labels or custom tags. I'll return to that in a minute. You could turn your laptop into a runner if you really wanted to. That's up to you. Then you will be working, and then all of a sudden your repo will connect to it and start having it doing a separate job while you're working. So not recommended. Also, maybe if that's all you can get, then it'd be a good way to start. Ideally, you'd have a dedicated server. So ephemeral versus persistent servers. Like I mentioned before, a server is just a computer. So me being relatively new to the programming world, I really do just want to point out that a server is just a computer. When we hear the term server, It's just a computer that exists to serve other computers or people, typically over a network. So for example, a web server serves web content. By default, Bitbucket, at least, uses temporary runners in the cloud. So it spins up an ephemeral server via a Docker image and then tears it down. However, you can also register your own computers as runners. And if you have a persistent server, as in a computer that is going to exist after the job is done, after the runner has done its tasks, then you can create, read, update, delete data directly to your computer. So for example, you could run one job on your computer and then store the results of it somewhere on that computer. And then when the next job gets run, those results or that data can still be on your computer because it's just a computer. It's like you've saved a file to your desktop, and now the next time the job gets run, that file still exists on your desktop. As opposed to with ephemeral servers, all of the desktop gets wiped after the job. So here I just have some screenshots of what it's like to install the Bitbucket runners. So this is specifically how to self-host a runner. So this is saying I have a computer that exists, whether it's in the cloud or it's on my desk, and I want to register that computer as a runner within the Bitbucket pipelines. So you'll see at the system architecture, we have options for Linux, and we also have Windows, and then we have those runner labels at the bottom. So again, if you have a ton of different runners, say you have 10 different computers and only 2 of them are Windows, then you can give them a Windows label. And then when you run a job that requires Windows, you'll say, hey, when I run this task, make sure you run it on a computer that has the Windows label. So that's what the runner labels are. They are just something you can have that you can include that are custom tags that when a job gets run, it's going to make sure that the computer has those labels. So after you call out which system architecture your computer has and what the tags or the labels are going to be for that runner, then it gives you a series of a script to run, essentially. And what this is going to do is this is going to be the thing that actually connects your computer to Bitbucket and says, I am a runner. So it's like registering your computer to Bitbucket saying, I'm online, I'm ready for action, I'm ready to start receiving jobs. On the left, you can see for Linux, this runner runs its jobs inside isolated Docker containers. So by default, Docker will not allow, basically within that job, you can't find any files outside of that Docker container. It's very secure in that aspect that it can't access anything on the actual Linux computer itself. It can only access the things within that Docker container. But with Windows, this runner, again, this is Bitbucket pipeline specific, it's not a Docker container, it's a Java process. So it is just getting run on the Windows computer, so you can access things like your desktop, your downloads folder, your documents folder. So, yeah. One thing I'll call out is that you need to register your runner in order to get it online, but you also need to re-register your runner every time your computer boots up. So if you registered your computer and then you shut it down and then you power back on, you need to re-register it, at least for the Windows setup. I accomplished this originally by setting up a task scheduler that runs the setup script every time the server boots up, but I found out later, I haven't gotten around to implementing it yet, but there's a better way, which they have a support article on called how to set it up as a Windows service. So if you are doing this for the first time, I'd recommend looking at that link because that is probably a much more reliable way of doing it than through Task Scheduler. Secure runner practices. just especially if you're working with a Windows server, Windows runner, your runner can read and write to your repo. Well, I guess that's relevant to both Linux and Windows. It's very likely that your runner can read and write to your repo, so I would hate it if you force pushed some sort of change and then messed up your repo. Be careful about that. Also, your server, if it's a server at your headquarters or even a cloud server that your IT team has given you, it likely has access to your company's local network, or it might, so just be careful of that. I'd recommend making your server a user account, not admin, and give it just enough permissions to do the pipeline job. And then also, you'll notice I had a bunch of different things blacked out and redacted in that setup script. That setup script is very confidential. It has a lot of unique identifiers in it. So you'll want to encrypt any sort of potentially sensitive material like that. Little overview of our runner. We have one runner set up for our team currently. That's it. It is a Windows server. I think it's an Azure server that our IT team set up for us. It is persistent, so it exists just as a computer out in the cloud somewhere. I connect to it using Microsoft's remote desktop connection, the Windows application. It has CET Developer installed with one main workspace. So you'll see in this little screenshot here, we have CET Dev. It's in the E drive, so E/CET Dev. And then we have one folder in there called main. That is our main CET Developer workspace. So if you were to open CET Developer and create a workspace, I created one named main. It also has a separate folder in there called pipelines. That is not a CET Developer workspace. That is actually the repository for the PowerShell scripts that get run during our pipeline. So I'll revisit that later. But just want to call out that we have one server that has one workspace and all of our pipelines code in it. All right, returning to the mantra. That was a lot. CI/CD is about scripts that control other computers. Runners are the other computers that get controlled and do the automated tasks. All right, the cast. Shells. What are shells? When you're controlling computers, there's two main ways, really. There's a graphical user interface, where you're moving a mouse around and you're pointing and clicking, you're double-clicking on a file, things like that. And then there's the command line interface, the CLI. So a GUI or a GUI and a CLI. So a command line interface is just typing out text commands. For example, when you do any git commands, git checkout main, you're typing out commands. A shell is the program that controls an operating system, that controls a computer via text commands without a mouse, with just letters and numbers. So on Linux, there's the bash shell, the born-again shell. On Windows, there's shells like PowerShell. So let's show some of the differences here. Well, before I get to that, what's shell scripting? So the shell is the thing that reads the commands and controls the computer. Shell scripting is, instead of writing out a series of commands into that terminal window, so here we have 5 different git commands in a row. Git clean, and then after cleaning, git reset. And then after git reset, git fetch. And then git checkout. And then git pull. So shell scripting is, instead of writing out all of those commands in the terminal in real time, you create a file that the shell reads. So it's just taking all the same exact commands, and then it's just putting it into one script that can be read. So now you can call this reset to main branch file in the shell, and it will be as if you've written out all 5 of these commands. So that's what shell scripting is. here's some shells and their scripts. To start with, and these are some, it'd be good to pay attention to these file extensions, because if you're looking through the base bin folder in CM development, you'll see a lot of these, so it's good to know what they are. .batch files, .bat, or .cmd, that's for command prompt. Command prompt is the terminal for Windows that was first released in 1987. So the command prompt terminal I have in the bottom left, and in order to create a script of commands that gets run, they would be .bat files or .cmd files. And again, this was 1987. Bash was first released for Unix-like machines, like Linux, in 1989. So Bash is just another way to control Unix-like machines, and then .sh scripts are scripts that can be read by the Bash shell in order to control the computer. So that one, last one was 1987, this one's 1989. Then PowerShell. So PowerShell first came out in 2006. So you can see it's almost 20 years later, or beyond 20 years later, from 30 years later from the 1987 command prompt. And basically what PowerShell is Windows came out with the .NET framework, which was this really great way of controlling the Windows computers and building applications and all sorts of things like that. So PowerShell was originally created as a way to leverage and use the .NET framework via commands, via command line interfaces, via a CLI. So if you see a .ps1 file extension that's not a PlayStation 1, that is a PowerShell script. So you can write out PowerShell scripts into a PS1 file and then call that file, and it will run those within the shell. One thing I'll point out is that you'll see sometimes you'll be using PowerShell version 5.1 and then sometimes version 7 plus. Version 5.1, PowerShell used to be Windows only, and version 5.1 was the last Windows only version of PowerShell. Version 7 plus is when PowerShell became cross-platform. So it now works on Windows, Mac, and Linux. However, in order to make it cross-platform, they had to reduce and pull out a ton of the functionality of PowerShell. So to this day, some people still use version 5.1 because they say there's more features available in there than even the latest versions of PowerShell, because they had to redact a bunch of capabilities. I actually don't know enough about PowerShell to say if that's true or not, but just that's why you will see 5.1 being used, even though they're on a much later version at the moment. All right, so shells. We talked about shells and shell scripting. Returning to the mantra, CI/CD is about scripts that control other computers. The shell is the program on the computer that reads the script and does what it says. YAML. We're on to YAML files. What is YAML? Proposed by Clark C. Evans in 2001 as an alternative to XML. It rhymes with camel. I thought that was pretty important to include in our presentation here. So YAML is a straightforward markup language offering an alternative to XML, borrowing ideas from C, HTML, Perl, and Python. So YAML, when it first came out, it stood for yet another markup language. And it is a document markup language that can combine a doc's content, structure, and metadata into a single file, just like HTML. So what does that mean? It's a markup language, and what a markup language is doing is it is capturing a ton of information in a single text file. So here on the right side, you can see an invoice, and it's almost like object It's like JSON, like object notation. There's information encapsulated in other information, and you can tell that by the spacing. And also they have the percentage signs and the colons and all sorts of stuff like that. So on the right, you see you have a buyer, and within that buyer, you have an address. And within that address, you have a city, line 1, line 2, postal, state. And we go back under the buyer. Now we have a family name and a given name. And this is what YAML was created for. It was a way of kind of nesting information so that it's easily understandable by a human, but it's also then could be parsed and interpreted by a computer. So this is an example of what it was created for. And then by 2004, actually shortly after it was created, the inventor changed the name from yet another markup language to YAML ain't markup language. So it became a recursive Y at the beginning of its name. And he kind of rebranded it, and he said, instead of it being a document markup like that invoice we saw, now let's just use it for data serialization. So the goal is to document data in a way that is easy for humans to read and easy for programming languages to parse, easy for a computer to parse. So here is some of the examples he included in his one of his spec release publications. So it looks like you have an array at the top, but then each hyphen is like a list. It's like going down in an order, a sequential list. You have Sammy Sosa, which then contains within it the home runs and the batting average, and so on. So that's what YAML became. It was no longer for document markup like HTML. It was for how do you contain data. Some things you'll notice about YAML. It uses a .yml, which I thought is kind of funny because it's meant to be an alternative to XML. So very close there. It uses a .yml or a .yaml extension. It uses the hashtag or the # for comments. It uses significant indentation for scoping, and what that means is spacing, white space. So you'll notice there's no brackets on here. It's just like Python in that the white space is used to figure out what scope it's inside of. It uses hyphens for sequences, aka lists. So it's going to run down from top to bottom, everything that's got a hyphen in it. And then it uses colons for key value pairs. So anything that has a colon, the thing that's next is the value, essentially. So here we have image as a colon, and then the value is cimage/base, and so on. So that is, YAML is just a way of laying information out in a text file so that it could be read and parsed. YAML is basically the go-to file format for pipelines. So a pipeline is defined using a YAML file called Bitbucket Pipelines YAML, which is located at the root of your repository. So again, this is the Bitbucket Pipelines version. The GitLab will still have its own YAML file. It just won't be named bitbucketpipelines.yaml. All right, so let's return to our mantra. CI/CD is about scripts that control other computers. The one YAML file at the root of your branch is going to tell your CI/CD service when and how to control the other computers. So that one YAML file essentially contains all the code for your pipeline, and your pipeline is your chain of automated tasks. So the YAML file contains the chain of automated tasks that should get run or will be run as long as the correct condition or event is triggered. All right, we got 2 left. We are on to repository variables and secrets. So a repository variable is a way of creating a variable basically through your remote repos web browser. So here on my Bitbucket website, I have created a couple variables that I can then access within my YAML file, within my scripts. So I have a GitLab access token and a GitLab username, because even though I am running a Bitbucket pipeline, I still need to pull base from GitLab. So I have those, and you can see I have them secured, which is why no one knows what they are, and I can show you guys a screenshot of it. It's got the little black dots, and that would be considered a secret, because now a developer can use the runner GitLab access token variable within their script, and they actually don't know what that access token value is. They can use the variable without knowing the value. So also then we have other variables that are not secrets. Like for example, I have runner base branch, version 16.0 official, and then runner cet dev workspace root. So there it is again. You saw it earlier when I brought up our persistent server. Our cet dev workspace is at the E drive in the cet dev folder in the main folder. So what's really nice about this is that an administrator can change the variable's value in one place. So here I can say say we transition from base branch 16.0 official to 16.5 official. I can come in here, change that base branch here, and now it doesn't matter what contents is within the YAML file of any of the developer's branches. Every time the pipeline gets run, it will pull this 16.5 value. So it's nice that you can change it in one spot. One thing I'll call out here, because it got me stuck for a bit, was it says at the top, to access a variable, put a $sign in front of its name. That's all it says. But really, that's for Bash. That's for Linux. So if you ever see %, variable name %, you will know you are working within a command prompt script. If you ever see $, var name, you, at least from an environmental standpoint, environment variable standpoint, you're working within a Bash script. And then in order to access an environment variable in PowerShell, you need to do the $env : and then the name. So for any of these on the screen here, I would need to do the $env : before it in order to pull its value. This is just recapping what I said about you have to do the $env, because this tripped me up for a little bit at first until I figured it out, and then found a support article later that called it out. So to show a little bit more, like I said earlier, we do keep two separate repositories cloned to our runner. We have our standard CET repository, and then we have our pipelines repository. So our CET YAML file calls PowerShell scripts in the pipelines repo. So what's kind of cool about this is that I can change the PowerShell scripts, and I don't require any of our developers to change their YAML files, because the YAML file points at a script in our pipelines repo. So I can update the pipelines repo, and any new pipeline that gets run after that moment, it will pull the script from my repo. Basically, if a developer has an old branch that they've pushed and they haven't updated it in a while, as long as the YAML file hasn't changed, they're still going to be pulling the latest pipeline scripts. All right, return to the mantra. CI/CD is about scripts that control other computers. So repository variables are variables that developers can use within scripts, sometimes without even knowing the value of that variable, a secret. Last one, artifacts. So each step or job within a pipeline can potentially run on different computers. It's very important to remember that. So if the first step gets run on runner 1, and then the second step gets run on runner 2 isn't going to have the files on runner 1. In order to transfer files from one runner to the other, you have to basically declare it as an artifact and put it in a specific folder. So files placed in the artifacts folder and called out within the YAML file will be carried over between runners. That's all an artifact is saying, hey, take this file and move it to the next runner in this pipeline. That was an easy one. CI/CD is about scripts that control other computers. Artifacts are the files transferred to the next computers in the sequence, in the chain of command, in the chain of tasks. Recap, the cast. Pipelines, chains of automated tasks that make your life easier. Runners, the other computers doing the automated tasks. Shells, the program that controls the computer. The program on a computer that controls the computer. YAML, it's the file format for defining pipelines. And again, it's just the format. It's just like the spacing. It's not actually the contents. Repository variables and secrets. They are variables you can call within a YAML file, within a pipeline script. And artifacts. They are the files transferred between the steps of a pipeline. Last part, part 4, the code. Let's actually get into the code here. And while I say that, before I actually get into the code here, I'm just going to do a basic example of an extremely basic YAML file. So here we have a basic pipeline example. A quick reminder here is that this is Bitbucket Pipeline specific YAML code. So if you are working with GitLab or GitHub, your YAML code will look similar to this probably, but it's not going to be identical. It's not going to be copy and paste. So this is a YAML file that lives at the root of our repository, and what it's doing, I'm going to read it from top to bottom. So first, pipelines. It's saying everything below is part of a pipeline, is a pipeline. So custom. That custom key, that custom text means everything below that is a pipeline that is manually triggered by the user. And when I say manually triggered, I mean there's a button on the Bitbucket website that you press run and you will manually trigger that pipeline. So it's custom, it's manually triggered. Now within that, we are creating a build and upload pipeline. So we are creating a manually triggered pipeline named build and upload. And within that, this build and upload pipeline has one step. This one step is named build and upload. This step, which could be thought of as like a job, as the task that's getting run on the runner, this step, we want it to run on a runner that has these labels: self-hosted and Windows. So in our situation, we only have one runner and it has those two labels, so it's going to get run on that. But here's where you can say, with this step and all the following commands, make sure that they get run on this specific runner. Then we get to script. So this script is saying, do the following. Cop clean, which is command line operator, which is for CET in order to work with CET dev and build the extension and all that stuff. So cop, we're going to first clean and repair the CET workspace. Cop clean, cop repair. See how it's listed vertically? It's almost like we are writing a shell script. We're just saying, do this, then do this, then do this, then do this. So we're going to clean and repair the CET workspace. Then we're going to set versions, which is set versions for Kimball International for all of our extensions. And we're going to increment the 4th digit of all of the extensions and packages. That's what set versions is going to do. After we increment all of our files, we're now going to start calling git commands. We're going to say git add all of those files that we've incremented the packages of, add them to the staging area. Then we're going to commit them with the thing incremented build number. That's going to be our message. And then we're going to push it. So now we've incremented the versions, pushed the latest branch, and we're actually going to do the build. We're going to say cop make. We're going to make all of the extensions within our group. And then once it's done making them, we're going to upload it to the build center. So this is an extremely basic pipeline that makes it so when a user presses the run button, it will increment the build and build it and then upload it to Build Center. This is a basic example of a pipeline. If at the bottom here, you could encapsulate all of the script commands into an external script file. So I'm listing like 10 different steps under that script, but we could just call one script file instead of listing those scripts individually, those commands individually. Which brings us to the advanced example, which this is the code, some of the code that we currently have in the pipeline I set up. One thing I'll call out is that I decided ultimately to use PowerShell as the scripting language. Originally, I started doing Emacs scripting because I figured CET developer has so many Emacs-based tools, and it's integrated so tightly with Emacs that we should probably stick with an Emacs. But then ultimately, I was like, it's like adding a separate thing on top of PowerShell. We're already working within PowerShell. PowerShell is already very powerful, so I decided just to stick within it. But you can call Emacs scripts within pipeline as well. All right, here I have our actual code in our YAML file, at least the start of it. So I will reiterate here that I am a couple months into learning PowerShell, and I'm, about a year or so into DevOps. So I'm not saying this is the best code, and if you have any, critique or recommendations, please feel free to leave them in the comments. But this is how things are working for us currently. So just going to kind of read down from top to bottom. Starting at the top, we have clone enabled false. What does this mean? So when a job gets started on a runner, if you think about it, the remote repository is reaching out to that runner, that computer, and the first thing it's going to do on that runner is it's going to run this job within a specific folder, or if it's a Linux, it's actually going to run it within a specific Docker container. It's going to run it in this location, this job, and it's going to clone your entire repository to that location to start. What I'm saying here is don't clone anything, because if you think back to earlier, you'll remember how with our server we have CET developer already installed, and we have a CET dev workspace already set up on our machine. So what we're going to do instead of cloning is we're just going to navigate to our workspace, the existing Git workspace on our computer, and then we're going to do things like git fetch, git pull, git reset, stuff like that in order to make sure we're working with the latest code. And we can do that because with the Windows process, it's just a Java process, with the Windows runner, it's just a Java process. It's not in an isolated container. If you were in a Docker container, you wouldn't necessarily be able to do something like this off the bat. You would have to set up some additional stuff. So don't clone. Instead, we're going to navigate to existing Git workspaces on our computer. Next, we have a definitions section. So you can see there's the word on the left side, there's the word definition, and then everything underneath it is indented to the right of that. That means that all of the following lines are contained within the scope of definitions. So everything below the word definition in the screenshot is contained within definitions. So definitions are reusable steps that can be called across pipelines. So if you have multiple pipelines and they all do something similar, for example, build test. If they all do something similar like reset, pull the latest Git branch, source code, you can write out those steps once here as a definition, and then you can just call this step from each pipeline. So the way to think of it is this is basically like creating a function. You're creating almost like a function called, for me, I have two different ones here. You have build test and you have reset pipelines branch. And we're creating the step in one spot, and then we can call this step from multiple pipelines, but we only have it defined in one spot. So, like I said, we have a step called build test. You'll see since it's a reusable step, we have an ampersand at the beginning, the and sign before where it says build test. And under name, we have just the name of the step, which is build test. Runs on, I'm not even going to talk about that anymore. Those are just the labels that we want the step to run on. In our situation, we only have one runner, so it is self-hosted, it is Windows, so really the runs on is not relevant with our setup here. But if we had multiple runners, that's where we would call out which runner would run this script or this step. So now under script, you will see we have one line. Remember in the last example, we had like 10 lines under script. And it was 10 different commands that get called back to back. Well, now what we're doing instead here is we are calling a single line, a single script, which is the build test.ps1 script. And you'll see we call a environment variable at the beginning, which I showed you guys a screenshot of before, runner pipelines root. So it's saying on your runner, on our server, go to this directory, and then within that directory, go within steps, and then call the PS1 PowerShell script called build test. So we've now narrowed it down. Instead of the 10 different commands getting called one after another, we are now saying call this one script. And so this is what I mean by saying that since these PowerShell scripts are in a separate repo, I can update this build test script and push changes to it whenever I want. And the YAML file won't require any changing because the YAML file is just pointing at this PS1 script. Underneath that then we have artifacts. So artifacts, what this is saying is any files within the build errors folder, the build logs folder, the build output folder, or the pipeline log folder, we want to transfer those between computers. However, if you go back to the very beginning of this presentation, you'll see that not only does this transfer it between computers, which is not necessarily necessary for our situation since we only have one computer, it's also taking all of those files and then hosting it at Bitbucket itself. So if in the beginning, when I clicked on a pipeline, and then there's the build tab and then the artifacts tab, this makes it so that you can download any of these files from your remote repository. So I can go to bitbucket.com and I can download the logs, the build logs of this pipeline job directly from the website. So that's why I declare all of those things as artifacts. You'll also see that it has asterisk asterisk. What that is doing is it's glob pattern matching. So it's saying any files within the build errors folder, just we're going to gather all of those. And then any files within the build logs, we're going to gather them. And the reason I laid them out as 4 different things, like you can see there's 4 different hyphens there, is because user, when you're on bitbucket.com, you can download the zip file of each of those separately. So I envisioned a situation where mostly people are probably just going to want to download the build logs. So instead of making it so that they have to also download the build output and the pipeline log and the build errors, I separated them out into their own folders, into their own artifacts, so you could download just one of them. So that is the build test, reusable definition, reusable step. And then we get to the reset pipelines branch. Very similar. This time it is calling the reset pipelines branch.ps1, and it's only collecting artifacts of the pipeline log because that's just like a git reset script. It's not actually building anything, so there's no build errors or build logs or build output. So what's missing here? Well, we have these steps, but we're not saying when these steps should get triggered, when they should get run. So now we're going to move past the definition stage, and now we're going to move into pipelines. You can see pipelines is brought all the way to the far left. It means it's no longer under the definition scope. It is its own scope. Everything following from pipelines on out is within the pipeline scope. So the first thing we have here is within pipelines, we have pull requests, and that is the event trigger. We're saying within this pull request scope, this is all the stuff that's going to get automatically triggered whenever a pipeline or whenever a pull request is created or updated. So here, what I'm saying is we have pull requests, and then under that, I do quote, asterisk, asterisk, quote. What that's saying is it's a glob pattern. It's saying any pull request that gets made. Here, you can call out specific branches. So I'm sorry, I should clarify. The glob pattern there, that is the source branch that created the pull request. It's not the target branch that it's pointing at. It's the source branch that you created the pull request for, or from that branch to the target branch. So what branches, you can call out different pipeline steps for different branches depending on when the pull request is made. So what I'm saying here is when any branch makes a pull request, we're going to run that reusable step called reset pipelines branch. And then we're going to run build test. So we use the ampersand before as the anchor in the definitions step. And now we are using the asterisk saying we're calling that reusable definition. So it's going to do two things. It's going to do one step of reset the pipelines branch, and then it's going to build a test. So what are the PS1 files actually doing? For example, this reset pipelines branch. What is it doing, and why do I want to do it at the beginning of a pipeline? This is really all it's doing. I kind of removed a bunch of debug stuff, but all it's doing is it's saying, okay, go to the root of the pipelines PowerShell's repo, local repo. So go to the folder where we have cloned our PowerShell scripts. Now check the status. I just do that so that it's in the log file so I can review later if anything goes wrong. Clean all untracked files in that location. Reset all tracked files in that location. Fetch the latest and prune any unneeded information from the Git workspace. Check out the pipelines. Make sure it should still be checked out, but check out the PowerShell repos main branch, and then reset hard our main branch to match origin. So all this does is at the beginning of every pipeline job, it is making sure that the PowerShell scripts are up to date. Then it calls build test. Well, what does build test do? Build test is a PowerShell script composed of a ton of other PowerShell scripts. So again, maybe there's PowerShell people out there that are cringing looking at this. Give me some pointers if you know better ways of doing it, but this is how I came up with it. Basically, I'm creating subscripts that all define what they do. So I'm going to walk through from top to bottom here. First, we are going to reset hard our base branch, so our CET developer base branch. We're going to navigate into that CET, we're going to navigate into the base folder. We're going to do a reset hard, similar to what I did with the PowerShell repo. Then I'm going to navigate into the ticket branch, or our extensions branch, and then reset hard that. Make sure it's up to date with the latest code for that branch. Then I initialize a bunch of variables all within a single file. It's probably not the best practice, but then I also print all of those variables so that I can see it in the debug log. It's like all of my variables and their settings when they start. I can review that in the logs. Then I have a detect previous build success based on key. So we'll talk more about this later, but basically I want to always run a build test on every single pull request that's created. But since our runner takes a long time, it's embarrassing to say that it only has 2 cores, so it takes about 20 minutes to do a single build, at least at the moment. I don't want, if someone makes 3 pull requests for a branch, which technically they'll only make 2 typically. If they make 2 pull requests, I don't want to spend 20 minutes building and testing one of them to find out that it works and then build it again afterwards. So now I spent 40 minutes building this branch instead of just building it once. So if it succeeds, I capture that as an XML file on our server using a branch name and commit hash key. So I'll return to that later. If this has not succeeded before, if this branch and this commit combination has never been built yet, then we're going to get the current XML version number of the extension. We're going to delete the logs in the CET developer workspace. We're going to build the extension. We're going to then parse the build log. And then we're going to record if this build was successful. We're going to gather artifacts. And then we're going to print compile errors. So the show build errors at the bottom. Basically, the show build errors at the bottom is what gets shown at the in the Bitbucket view where you saw the errors ASCII stuff at the beginning. I'll show you this later. So let's dive into a little bit more. What is this build extensions.ps1 file doing? If we look into it, this is it. It's making sure we're within the CET developer workspace, and then it's cleaning any prior builds, repairing the CET dev workspace, and building the extensions. That's it. Let's look at a more complicated one though then. We have build log parse. So the reason I made this was because, again, I wanted to be able to capture the actual compile errors and deliver them to the developer without them having to open CET developer. So how are we going to parse the log files? Looks something like this. So instead of going through line by line, I'm just going to read my notes off to the right side. First, we're going to create a build errors folder, and we're going to create a build errors file to capture any potential compile errors. Now we're going to parse through the log files for each extension. So we have this for each for loop, and we're going to go through the log files for each of our extensions. We have 6 extensions. First step, we're going to go into build status.xml. So whenever CET developer, whenever cop builds, or just build center, whenever CET developer attempts to build a extension, it creates a build status XML, and that is an easy way to tell whether the build succeeded or failed. So I'm going to go into that XML file and grab the value of the extension build info's build status. So here's an example of what those files look like. This is when a project is built, it'll do the build log.cm text, but it'll also do a corresponding build status.xml. So if we go into that XML file, we're looking within extension build info, within build status. Here we're going to see whether it's a success or a failure. If the build status is errors and it doesn't say success, then I'm going to grab all of the content of build log.cm text as a single string. I'm then going to go through and remove all of the Emacs control character formatting. So CM text has all sorts of different color coding formatting built into the text file, which if you've ever opened a .cm text file in like Notepad, you'll see. And it is in order to help show the formatting within the CET developer application. I want to capture this information as just regular text without that formatting. So I'm going in and I'm removing all of the control character stuff. Then I'm grabbing all of the text using regex, grabbing all the text between compile error and /compile error. I'm then filtering out any duplicate errors. So if the same error has happened multiple times in one extension, I'm just making it so that it only shows that error once. And then adding a bunch of line breaks in order to make it easier to read. And then I will append an errors section for this extension in the build errors text file. I will append all unique errors, and I will do this for all the extensions that have had errors. So one thing I do get called out about is I'm not using /newline. I'm using right host with empty quotes. That was a stylistic choice because I was trying to give myself more space, but it may be hard on the more advanced user's eyes. But yeah, so this is an example of using a PowerShell script in order to take the log file and actually pull the information I want out of it and put that information into a separate file called build errors. At the top, you could see actually it's the second line down or third line down. It says the full name is build errors, build dash, and then it uses the current Bitbucket build number, and then branch, and then it uses a Windows file safe version of the branch number, or of the branch name, because I realized that Windows restricts you from using certain characters in a file name, but Git allows you to use those characters in a branch name. So we have to make sure that we are converting any non Windows acceptable characters into a Windows acceptable format if we're going to save it in a file name. So the result here is this is the build errors file that is created. It just pulls the log out and it creates it as a text file. And then, like I mentioned earlier, I have the check success log where you can see with the two highlighted pull requests, the first time it got run, it took 19 minutes to do the build test, which succeeded. And so then the second time that it ran the pipeline, it only took 1 minute and 45 seconds because it checked and it saw that it succeeded. There was a success, so it didn't need to actually run the log. Also, this is very inefficient. I could set this up so this should be able to be accomplished in a couple seconds, not 1 minute and 46 seconds. Also, this could happen faster if we boost the power of our server. So again, this was just a starting point. Once I'm able to dedicate more time to it, I have a plan in my mind to get these numbers down. So here we have, this is our build test still. And if you'll notice what's missing, it's not uploading anything. It's not uploading to Build Center. It's not publishing anything. So now I'm going to show how we actually get it so that when you go to Bitbucket and you press the Run Pipelines button, then how do we get it so that it will actually upload the build to Build Center? One thing to note within Bitbucket Pipelines is that you have very limited, but you have the ability to allow for user input. So when I select, I'm going to read from top to the bottom there, there's branch 16.0 pipeline. The type of pipeline job we want to run is called build custom upload only. There's a variable that I can set while I run for this pipeline. So under set version number, by default, it loads with the word increment in there. So the way I have it set up is that if you leave it at that, it will always increment the last number, the fourth build number, or you could manually type a number in there and it will set it to that version number when you press run, or you could delete it so that there's nothing in there and then it won't touch the version number at all. So once you create a variable that a user inputs through a manually run pipeline like this, you can access it within the script as an environment variable. So with the $env:. So here, now on the script on the left, you'll see we had the pull requests at the top underneath the word pipelines. That was automatically triggered pipelines when pull request is created or updated. Now we are on to manually triggered pipelines, which are within the custom scope. So I have a pipeline called build custom upload only. It has variables. One of those variables is named set version number, and the default is set to increment. So you can see that variables scope is where you call out the things that you just saw in the last 2 slides ago of where the user can enter in variables that you're going to run for that pipeline. Underneath that, the first step of this pipeline is reset pipelines branch. So I am calling that same definition that we established at the beginning, where it's going to make sure that our pipelines PowerShell repo is up to date. Then I'm going to run a step called build and upload. And this is going to, if we look under the script tab, or script scope, it's going to first set an environment variable called publish to. It's going to set it to upload only. And then it's going to call the build and publish PowerShell script. So, and then once it does this build and publish, it is going to then gather some artifacts as well. Here I have another pipeline, very similar. This one, instead of being called build custom upload only, this one is called build publish beta. And if you'll notice, it's the exact same thing. However, prior to build and publish.ps1 getting called, instead of setting publish to as upload only, it's getting set to beta. And then by default, the set version number is getting set to increment. So the build and publish to beta pipeline doesn't ask a user whether they want to increment or not. It just always increments the last build number. I'm going to change this as we've lived with this pipeline. It would be nice if we had that functionality, but just showing that this is how it's set up currently. So it's interesting, we are using the same exact PowerShell script. The only thing that's different is the environment variables. So let's look inside this build and publish.ps1 script. This is almost identical to the build and test script, except it deletes the existing logs. I think that was in the old one though. But here now we have the set version number. The build test, we are not setting or updating any version number. We are just building the branch as it exists to make sure it compiles. So here we have a separate script called set version number. And then we have another one called commit new version. And then we have a one final script at the bottom highlighted called publish extensions, which actually takes the build and then uploads it and or publishes it. So let's look at what's happening with the set version number. So you might know that COP already has a way of incrementing version numbers. However, COP increments the packages and the extensions version numbers. When we do a build, we only increment our extension numbers and we don't increment our package numbers. The reason for that is if we have a developer and they're working on a bug and they need to do load code for their bug and that package is on package 001, so then they build load code, they increment that package to 002, and then they build load code and say if the package is below 2, then run the load code. Well, if that ticket got held onto and now it's 2 weeks old for some reason, and then all the packages got incremented, now their load code will no longer work. So what we've decided to do as a team is we just don't increment the packages, we only increment the extensions, and then we basically reset all of the packages to match the default when we do a migration. So this set version number is to only increment the XML files extension versions. It's not to increment any of the packages. And that's what's going on in here. I just want to give some more examples of PowerShell in action here, really. So in this, I'm just going to read my notes. What we're really doing is it's going to say, okay, first, if we don't know our extension.xml's current version number, let's grab that. So we know what is the current version number of our extension. Then, for each extension being built, let's first determine the file path of the extension.xml. And if that file doesn't exist, throw an error because that file should exist. So we need to just make sure that's there first. Then we're going to get all of the contents of the XML file as an XML. And we're going to get it as an XML because that's going to allow us to drill into the different tags essentially and just replace the information we want. It's just easier treating it as an XML file than as like a raw string or something like that. So then we get into the kind of conditions of what is the set version number. Remember that number that the user could enter in during that run pipelines little UI. If it's set to increment, it's going to turn the string, number into an array of 4 numbers. It's going to grab that last number, increment it, and then turn it back from an array into a string. And that is if the user had it set to increment. Otherwise, it's going to take the set version and it's just going to just set it to whatever number the user typed in. And I didn't show it in here, but I'm pretty sure in the initialize variables section, I have some regex filtering to make sure that whatever number they type in to that section is actually a valid version number. So they can't just type dog and then your version number becomes dog. So then at the bottom, we go into the XML file, we set the new version number, and then we save the XML file. So again, just showing one thing we did with, or I did with the, within this pipeline. And then we have the publish extensions.ps1 file. So publish extensions. I wanted it so that there were kind of 2 features. One is that it takes the build and it uploads it to Build Center, and that's it. So then a user has to go in, or a developer has to go into Build Center and then actually host or add the build to a distribution. However, I also wanted it so that it would publish to a distribution automatically. So what I have going on in here is if publish to is null, or if there's build errors in this file, don't attempt any upload or publish. Even if you're supposed to upload or publish, if there's errors, don't upload anything. So that's the first check I do. Then I create an upload name, which is kind of a jumbled mess, but it creates an upload name which concatenates the current version, or rather the newly incremented version, the newly set version, plus the current branch name, plus the current time, just to make sure that if we upload two uploads next to each other, that they're not going to overwrite each other or anything like that. Just to give a unique key within it that will make sure there's no duplicates. So if the environment variable of publish to is set to upload only, then we run the command cop upload extensions with cop upload these extensions and use this upload name. However, if we do have a publish to set to one of the various distribution names, like alpha, beta, or RC, then it's going to check and make sure that the distribution name is valid. And if it's not, it's going to upload it only. It's not going to attempt to publish it if we don't know that that's a build box. And then it's going to upload with the name and publish to the distribution and set the publish success to true. So again, just two different ways. We can upload it directly to the Build Center, or we can publish directly to the directly to the build box by doing the /publish to distribution flag parameter. All right. Wow, like an hour 40 minutes into this, much longer than I expected, but try to close it up here. I got some bonus here of Teams notifications, because this was an important ask, and we couldn't figure it out, and then someone else at our company did. I wanted to share it. So if you are interested in Teams notifications, it's not easy, especially to do it in a secure way, but one of the other people at our company figured it out, and I'm very grateful for him. And so I just wanted to share because I thought it was pretty clever the way he did it. This would require, having admin access, IT admin access, which I, as a developer for CET, don't have. So you may not have it, but if you are trying to get Teams notifications into your pipeline, this is one way to do it. Basically, what we have is in PowerShell, I basically send a log message to Seek, S-E-Q. This is a platform and application which is a centralized logging server for our company. So basically, I am just sending a log message to our centralized logging server. And then what my coworker set up was, when it receives a specific message from our application, it then forwards that message to an HTTP app plugin. That app plugin forwards the message to Power Automate, which is kind of like the quote-unquote no-code way to automate workflows within a Windows system. So the plugin forwards the message to Power Automate, and then Power Automate forwards to Microsoft Teams. So this is what it ends up looking like for me. If the build fails, then first I create this custom PowerShell custom object. Within it, it contains things like action, which is open the URL. When you click on it, it's going to open the URL. The title says pipeline results, and then the URL is generated by the Bitbucket build number. So we create this PowerShell custom object, which is a button, and then we include that button in our message to the Seek centralized server, the SEQ log. So you can see at the bottom we have a message template. It says pipeline failed, message properties. It is a direct message, and the message recipients is me, Derick Downey, and message mentions is me, Derick Downey, and then the call to action is that object I created at the top. So I'm sending structured information to our centralized logging server. Our logging server receives it, and it looks like this. It just receives it, and it looks like this, and then it's going to take that, and it's going to forward it to the HTTP app, which then goes to Power Automate. What happens during Power Automate, I do not know. Honestly, I apologize if you are interested in figuring this out. I don't have the answer because I didn't do that, but I do know it's possible. So I'm at least coming here to tell you that it's possible and have hope. And then the end result, this is the pipeline failed notification I would get in Teams. So there's that pipeline results button that when I click it, it opens up the URL to that pipeline. Conclusion. Lessons learned. Highly recommend not starting this while in the midst of major team transitions. Our team totally was absorbed by another team at one point during this, and our Git workflow is basically the moment I got everything working, we started having meetings saying, hey, everything's going to change about our Git workflow. So that is not fun. Or do start while in the midst of major transitions, because then you'll learn a lot. Another thing is that there is a lot of fine-tuning and support required. This is not the type of thing that you set up and then you're like, I'm done, I did it, hooray. It's going to require a ton of maintenance, especially to start, especially if you don't know exactly what you're doing to start. For example, things like, it turns out I was saving to a file that has that the file name includes the branch name. Oh, but Git branches can use characters that Windows files cannot. So there's just a lot of weird things that you got to massage out of the system. So just recognize that it's something you're going to be committed to and you got to maintain, take care of. I would also recommend making sure that all failures get sent to whoever's maintaining it or whoever's setting it up so that you could assess, okay, did this actually fail because of their code, or did this fail because of a pipeline issue? You know, like recent things I've seen is, I stopped a pipeline, but I stopped it while I was in the middle of a Git process. So the index lock was still present on the server. So it failed because it couldn't pull any of the latest code. That's not a code issue with the code submitted. That's a pipeline issue. So type of thing I wouldn't know if I didn't if I didn't have all the notifications sent to me. And last, I would recommend, there's so many things you can do with these pipelines. There's so much opportunity, and I get so many ideas for types of automation we could set up. And so that's why we just started with this build, test, and automated build tool, essentially. So just set it up so that it does very, very basic stuff, and then you can slowly add on the additional features from there. But just get the minimum viable product working first. Future goals, just mentioning again that I guess I don't need to talk about this again, but just want to reiterate, now that you've seen all of how it works and how you can trigger commands through the pipeline, it really, I hope that maybe if I give this presentation again in a year or 2 or 3 from now, you'll just see all sorts of astounding automated CET tests, because there's a ton of opportunity with this, and maybe you guys can crack the code first and tell me about it in the comments. So that's me right there. Thanks for listening. This went a lot longer than I expected. I apologize if I was rambling, but I hope you were able to take some things of value. And if you have any questions, leave them in the comments. Thanks and good luck.